Hi, this video is going to be on about how to find the slope of a linear line. So when we talking about the mother and father of equations, I've mentioned, okay, what's the slope look like? Is it steeper or is it flatter? And those have been very basic definitions of what exactly is slope. This video is a concrete, this is what slope means. So here we go. This video is also about finding the slope of a linear line, not a line. Like if I gave you a quadratic that looked like this, they have that curve, don't they? So when it curves, the slope's actually changing. And here's a little preview. That's what calculus is about. When you take the first semester of calculus, when you get to high school or first year of high school, or sorry, the first section which you take a year in high school, but if you wait till college, you'll take the first semester. It is about finding the slope of a line, any line. This is specifically about what is the slope of a linear line, because the linear line does not change. So that's why this is what we do here, because, well, it's a lot simpler to understand. But this definition, you will take with you all the way through college. If you go into calculus or engineering, you've got to know this definition. Slope, this is where the money's at, right here. So pay attention. Here we go. The slope, if you haven't read already, is the ratio of a line's vertical change, that means how much it changes going up or down, to its horizontal change, left or right. So like if I go up by 5 and backwards by 6 or something, like that's what slope is. And don't worry, that's what this whole video is about. How it works. The most basic idea is this equation, and this is literally the equation, not using minuses, just with like definitions. Slope, they usually use the symbol m, that's the letter they use for slope, is equal to delta y divided by delta x, because that's what ratio is. It's me dividing something. Delta just means change. So really it's a fancy way of saying the change in y over the change in x. So I just wanted you to think, like, how much is it changing in y? Is it going up by 7? Is it going down by 6? Up is positive, down is negative. Is it going forward by 5? Is it going backwards by 9? Forward is positive, backwards is negative. So those are kind of the ideas that we're going to play with right now. So here we go. How is m used? Here we go. So again, I just gave you a little definition because the algebra is about using symbols to represent numbers, and we got to talk about that. M is used through math. Throughout all of math, the letter M is used for slope. That's what, if I see a letter M, even in my class, I'm thinking slope. Well, I'm thinking manifold lately, but that's because of the class I'm in. God, I love complex analysis. Go to grad school in mathematics. It's great stuff. Delta literally means delta. In Greek, that's what this word was said. It was called delta, and it just meant change. So you'll notice when you get further and further in math, a lot of symbols are stolen from the Greek alphabet. So kind of a neat little thing that the Greeks will forever have a hand in mathematics on the planet Earth. On the planet Mars, well, I don't know, because I've never been before. I just totally remember what movie's playing this weekend. I'm really excited. Go watch that movie, John Carter. If this is like not during the year John Carter came out, it looks like a really neat movie. The next video, I'll probably be sitting here complaining about how much it sucked. Okay, those are the definitions of slope. So what does it mean? Go ahead and copy this graph. And by the way, when I give you these graphs, I really want you to do a good job, because if you don't do a good job copying these graphs, it's really hard to understand exactly what's going on. So here's a graph that I would like you to copy. Pause. Unpause. Okay, so this is a linear line. Just going to throw that out there that is what it is. I'm also going to throw it out there that I don't have a pencil with me. Give me 2 seconds. Damn, got my pencil. Okay, sorry. Pause that. Here we go. What is slope? Well, let's say I wanted to find the slope between these 2 points. So what I'm going to do is, well, if we take literally the definition, It is the change in y divided by the change in x. So I'm going to take this one right here. I'm actually not going to use a pencil. I'm going to use a color pencil. So I'm trying to be all fancy like. And what I'm asking is, how far is it from here to that point? How far up do I have to climb to get up to that point? Well, when I climb up that high, you'll notice I am not at that point. So now I have to go forward a little bit. And yes, that colored pencil does suck. I can't see it either. I'll use this one instead. It's all right. Okay, so let's just zoom in on these two little lines I've added right here. I went up by how much? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And then I went forward 1, 2, 3. So plus 3. Because I went forward, it's plus 3. Okay. So I went up by 9, I went forward by 3. So let's go down here to my, I'm going to find the slope on this line 3 different times. I've got positive 9 because it's the change in y. So why don't we first put that? Delta y divided by delta x, which is equal to 9 over 3. I went up by 9, I'm going forward by 3. Simplify it, and it's 3. I would even make a point to point this out. I'm actually going to make the point that I can simplify it to 3 over 1, which is equal to 3. This 3 over 1 is a really neat idea, and this is going to get talked about in 2 videos on the slope-intercept movie. But if you ever see the slope 3, I'm really thinking I go up 3, I go over 1. I go up 3, I go over 1. 9. I go up 3, I go up 3, I go up 3. I go over 1, 1, 1. That's what happened. I went up 3 times, I went over 1 3 times. Cool idea, right? So, hey, the slope's 3. Awesome. What if I changed the question? What if instead of finding the slope between those 2 points, what if instead I wanted to find the slope between 2 other points? What if instead I did this? I always do my vertical change in y first. So what if I started up here, and I said I go down, so I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I go down by 15, and then I'm going to go backwards, which is negative also, by 1, 2, 3, 4, 5. So my vertical shift down, my change in y going down, was negative 15, and my change in x was 5, negative 5. A negative divided by a negative is a positive, and this still simplifies the 3 over 1. Hey, look, that is 3 also. That's the magic of slope. It doesn't matter what 2 points I pick. As long as I pick 2 points, that is all that matters. Really cool idea, I think. And of course, my opinion is all that matters. Normally, I would argue this. I would argue this idea. I'm going to choose I'm going to choose the 2 closest full points I can find. If you notice, I did my line with a ruler. There's another point right here. I usually start at the lower. I always go up with y, and then whatever happens if x happens. But I can go up by 3. I go up by 3. I'm going over by 1. Forward by 1. So that's really neat. So the change in y over the change in x is already equal to 3 over 1. which is also equal to 3. A linear line, the slope is the same no matter what points you choose. It's the magic of slope on a linear line. On a quadratic, the slope clearly, it changes, which we'll talk a little bit more about that in class. All right. Again, absolutely. Let's think about these two lines. Well, we've got some craziness going on here. Let's jump right in. Thought you'd never ask. Maybe you're thinking you thought I would ask. Oh man, he's gonna ask that, isn't he? Yeah, I am. Here we go. Fancy ruler. See, this point is on this line, so I gotta go down by 3. So I'm going down by 3, right? Cool. And I'm going forward. So it's plus because I'm going forward. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I go forward 15. So you might be saying, okay, what's the slope of that one? Well, I'm going to call that my first line. So I'm going to put a little. I'm going to change this. Don't call that 1 and 2. Let's call this line L and line M. Fancy L, right? I know, fancy L. I'm calling the blue line, the turquoise line, line L. So we want to know what the slope of line L is. So that's how I would signify this is the slope of line L. Well, it went down by 3. So that's minus -3, and I went forward by 15. I'm going to simplify this fraction to 1 over 5, right? Divide top and bottom by 3, and I'm going to put the negative into front. I'm not going to leave it on top and bottom. So the slope ends up being negative 1 over 5. Cool. Let's find the slope of the other line. By the way, notice that that line is father. It has a negative slope. Did you notice that? Are you connecting that? The problem we just did over here, that's a mother line. It has a positive slope. Heck yeah, Mr. V. Oh man, totally get it. I'm in. If you're watching this at home, I want you to right now say, Mr. V, I am in. I'm down. I'm savvy, as Captain Jack Sparrow would say. Okay, I'm going to drop by how much? Here we go. By the way, it doesn't matter what point I choose. Choose whatever you want. Down to here. And I'm drawing an arrow to show which way I'm thinking. That way I know why I'm doing it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Minus 18. Okay. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yes. Yep, that's 18. You're probably sitting there reading my mind. Mr. V just messed up. And you're totally right. It doesn't matter for this problem. I'm going to do this. This is fine. 1, 2, 3, 4. Minus 4. I'll talk about why it might have mattered in a minute. So this is equal to changing y is 18. Changing x is -4. Negative divided by negative is a positive, so who cares? 9 over 2. And I would, generally, you leave your slope as an improper fraction. You would leave it like that, 9 over 2. Originally, the idea was this is supposed to be done right, but if you notice on my graph, this is not labeled correctly. This was supposed to be a 12, and this is supposed to be a 14, which means my point was supposed to be 2 more lower, but that's not going to matter. The reason why I was going to point something out was, and it totally makes sense why it doesn't look like a right angle now, if two lines hit at a right angle, I can multiply their two slopes together, and if it equals -1, then they were perpendicular to each other. This is not going to equal -1, so we're not going to worry about that. So basically look at that and like, haha, Mr. V, what a silly guy. Silly goose. Here we go. Example number 3. Oh, sorry, let's talk about what exactly now. I'm like completely confused because now I'm really annoyed because that was going to be a really cool problem. Oh, well, it's all good. Slope equation. No graphing required. There's a way of doing this without even using a graph, which this is a huge thing for this year and also for next year. It saves you time. You don't have to go through putting axes up. It's a really neat trick. If m is the slope and I have y2 minus y1 divided by x2 minus x1, so if I gave you 2 points, these 2 points, x1, y1, x2, y2, so this is point 1, this is point 2. If I give you these 2 points, you can take their x and y pieces and basically find the slope just using those. So I'm going to do that right now. Example number 3. If I have the points 4, 12, and 2, 6. So I'm going to just real quick, this is x1, this is y1. This is x2, this is y2. And that's a great idea to do because that'll help you so much if you label it right now. The equation is m equals y2 minus y1 divided by x2 minus x1. You start with that. Well, you got 6 minus, because that's y2, 12, divided by 2 minus 4. 6 minus 12 is -6. 2 minus 4 is -2. -6 divided by -2 is +3. The slope is 3. No picture, no nothing. But I will show you this right here. 612 is this point, or 626 is this point, and here is 612. I just found the slope of this line right here. We know this slope of this line is 3. So I think that's kind of cool to go back that I basically just use these points without using the graph at all. Really neat trick. 10, -13, which of course, if you notice just now, I messed up that problem, so it should be I'm just going to change that to an 11, so it is on that picture that I'm going to go back to in a minute. Again, slope is equal to y2 minus y1 divided by x2 minus x1. This is x1, this is y1. Could you put x1 and y1 right here, and x2, y2 right here? Yeah, it doesn't matter. It does not matter. 7 minus -11. Do not lose that negative. So huge. 14 minus 10. Well, this is two positives. So this is 18 over 4. Divide top and bottom by 2, we get 9 over 2, which is the slope. Which, hey, look, that's what we had on my picture over here that I did wrong. That's the slope of this purple line. Oh, no picture required. How you do it's up to you. Quite often you will get a problem where they just give you 2 points and say find the slope between these 2 points. A very common question you'll start seeing in the next year or two. In my class, you'll usually get a picture and I'll ask you what the slope is. That's pretty standard. So again, up to you. 2 different ways, but usually for you guys I would say stick to the picture idea. Seriously, the picture idea is huge. Look, I make a right triangle every time. If you didn't notice, that's a right triangle. And it's very helpful with the arrows. Color coding makes it pretty. I love pretty. Have a great day, guys.